This video is brought to you by Sporlan, quality, integrity, and tradition.
About a week and a half, 2 weeks ago, we were in a heat wave and we got a service call on this AC. Well, amongst all of our other service calls, we had a ton of them, but we had a service call and the unit had some bad fuses. I had a technician come out, didn't find any direct shorts, couldn't find a reason for the fuses to blow, so we replaced them, and the unit's been running for about a week, week and a half, 2 weeks, somewhere in there since. So we didn't blow the fuses again, but I'm here today because we're kind of slowing down and we're getting a little caught up on some of our chaos and all the situations we had to triage. And now we're just trying to follow up and finish up some things. So we're gonna go through this AC, see if we can figure out a reason why the fuses would have gone bad. We're just gonna start from scratch. Now, obviously they're not blown right now, so that's a good sign. This is our electrical control area. The unit just satisfied, it was running. So both compressors have shut off. I'm just looking to see if I see anything obvious. No burnt wires that I can see yet. Everything looks to be decent. Contacts kind of look like they might be burnt a little bit inside there, but we'll have to investigate that a little bit more. Pull that out. Let's check. We'll have to get these covers off. We'll investigate those. This is not good. This is not the right hole for that electrical to come through. This is not the hole that has a beveled edge. This one is just a raw edge, so that's not a good thing. That's the main power feed just sitting there potentially rubbing through, so we'll have to investigate that. Let's get a meter out and see if we have any safeties on this guy. This guy does have a compressor lockout board, so if either one of the boards sees a low pressure, high pressure, or a freeze stat, it can lock the unit out. Now, I know the unit was running when I got here, but I don't know that both compressors were running. So what we're gonna do on these older ones is you just gotta jump between X and C. Make sure you do not have a 24-volt call, okay? So far, that's a good sign. Now we're gonna go between C and R to verify that we have 24 volts. Yes, okay, so we are not off on any lockout situation on either compressor. At this point, we can power down the unit because we know we don't have any lockouts. Now on these older units, if it has a lockout and you power it down, you just reset it. So you wanna be sure that you weren't in a lockout situation before you deal with that. So let's go ahead and power this guy down. And we're gonna verify power's off, and then we'll get in here and start checking the contact points. First thing I'm gonna do is I'm using an insulated screwdriver, okay? We're gonna make sure that incoming power is tight. Yeah, nice and tight. Nice and tight. Nice and tight. Now, notice that those are lugs, and on the bottom there's Phillips head screws. Let's make sure those Phillips are nice and tight too. Making sure that everything's good. Yeah, that feels tight. Yep. It was a little bit loose, but not crazy. Now we're just going to check the bottom real quick. All right, disconnect's fine. So let's look at this. So these wires are basically sitting in an unprotected spot. Now, on the back, let's look at this. That's a beveled edge right there. Okay, that one's meant to have wires running through it, but this one needs an electrical connector for wires to run through it. Now I have power turned off, but let's investigate these wires. Do we have any damage? Doesn't look like they're rubbing out, but I mean, you never know. It won't be hard. Look at these old units that don't have grounds either. It wouldn't be hard to fix this, because if we replace the contactors and we put contactors that all have lugs, then I can terminate these wires directly on the contactors. And it looks like the wires might even be long enough to do that. So that'll probably be part of our repairs today, but we're gonna keep going trying to find an actual cause for why this ruined a couple fuses. All right, things that can cause fuses to go bad, run capacitors on PSC motors, because the motor can pull high current with a low capacitor, cause issues. So let's go That one's 9.7. This is a 10 microfarad capacitor, plus or minus 5%. So 9.5 would be our threshold. Let's go to this one. And this one's at 9.3. So this is a dual cap. Slightly low on the right side. The left is within range, but I will also say that we're using a 9-volt battery in my meter that's kind of dying. Looks like it's dead. So we're gonna go ahead and change this. Put 2 new capacitors, 1 for each motor. We'll do 2 individual capacitors. Electrical connections on the compressor. There's some spider webs in there. But other than that, I'm a little concerned because this one has some rust on the terminal, which makes me wonder if we've been flooding back. We'll blow those out with an air blower. The condenser, it's hard to tell how clean it is. There's spots that I can actually see through it, but it's hard to say like how good it is. As far as electrical for the condenser fan motors, I don't really see an issue there. Those look fine. Indoor blower motor over here is definitely dirty. Man, look at this. There's gonna be places all in here that there could be potential rub outs. That's all low voltage over there, which most of the low voltage has actually been disconnected. But this, well, I guess this isn't too bad, but like potentially right here might be a rub out spot. Look at that. That actually is 100% a rub out spot right there. That is the low voltage though. That's the control voltage, but still, that's a rub out spot we gotta fix. We're looking for high voltage. This thing, it's not over tightened. Bearings certainly don't seem like they're completely stoked. Pulley's not bad, I'm feeling it. Don't feel too many issues there. Okay, well we definitely got to fix this. There's a rub out spot. There's a lot of nastiness in here that people aren't cleaning up. High voltage, so let's get these capacitors and let's get that repaired right there, and then we'll keep going. Yeah, see, look at this. The low voltage that was rubbing out over there has been bypassed right here. Don't know why it's been bypassed. That shouldn't be good. Investigating this a little bit further right in here. So the low voltage, we know it had rubbed out. You can see a rub spot in the low voltage, okay? But for whatever reason, that's been bypassed right here. But looking at the high voltage, there's actually a spot on this black wire where it looks like it could have rubbed out. It actually went down into the jacket right there. Almost. So that could be a spot that potentially could have arced. I mean, you definitely have something going on there. So I don't know if that's all just from the low voltage, but we'll repair that. Looks like we got a little slack right here, so we can probably pull it out and do what we got to do with that. All right, we got this all pulled out of here, and I don't have a 3/4 chase nipple, but I had a 1-inch one. So even though that was beveled, I still put it on there because we're gonna pull all the wires through there. So there's high voltage from the condenser fan motor going through that, and it's got the protection on both sides, and then we're going to pull main power up through that, and then we're going to terminate it. We're going to replace these contactors with lugs and then terminate it properly in those. This one is slightly burning, but it's not bad. But again, we're going to replace them and just get the lug ones. This one doesn't look too bad, so I'll decide whether or not I'm going to change that as I'm pulling these apart. All right, we went ahead and replaced all the contactors, terminated the power directly in the top, eliminated those wire nuts and all that stuff going on in there, okay? Still a rat's nest of control voltage wiring, but it's secured up there. And then we changed the capacitors. We went with 2 individuals, and I strapped them together, strapped them to the back wall. Now we need to fix this wiring right in here. Going through, there was a bunch of economizer wires all right here, and they were actually all disconnected. They were in here just wire nutted or taped off. So the economizer's been disconnected. I'm eliminating those wires just to get them out of here, so that way there's just not bunches of wires doing nothing. We secured the high voltage for the indoor blower, repaired a section, zip tied it in a way that it's not rubbing up against anything. We still gotta, I'm gonna hook up this control voltage in this blower motor back into here. So we're just gonna get all this disconnected back here. Yeah, it's kind of nice to get rid of some of this stuff that's not being used anymore. That's the heater limit safety. but this sensor is not going to be used anymore, so I'll get that out of there. All right, we got all the economizer stuff disconnected back there, eliminated. We've got the high voltage right here. Now, typically you don't want to strap low voltage to high voltage. This is a short run. I don't think we're going to really run into any problems, but I did zip tie these right here. You can get some EMF feedback or whatever from the high voltage in theory. I don't think it's going to be a problem here. If it is, we can redo it, but this is how it's always been ran on these units, where the high and the low get strapped together going right here. So I think we're going to be okay. So we're all secured in here, eliminated all the junk, splice connections, all secured in here. All I'm going to do is find out the current draw, the RLA of everything, and then we'll put all the covers on and we'll test current draw from in here when the unit's running. As we're cleaning up, I'm just kind of observing, just kind of cleaning up trash. What I did notice is something right here. So look at Y1 and Y2 are jumped together, first and second stage. That could cause the fuses to blow if they both came on at the same time and we had a heavy load on the unit. I don't know why they're jumped together, so we're going to go ahead and flip them around the way they're supposed to be. Don't know why they use yellow for Y2, but that's just what it is on this unit. And I'm looking at the schematic. So compressor lockout board 2, compressor lockout board 1. So this one goes to 1, the other one goes to 2. So yeah, we'll try that, and then we're gonna probe up on this unit and start it up and check current draw of everything. And I wrote it all down. RLA of condenser fan motor, RLA of indoor blower motor, and RLA of compressors. So that way we can test it right here. This guy's been running for a little bit. I have it jumped Y1, Y2, everything's on. We haven't checked current yet. But as far as operating stats, first stage, not bad at all. Superheat, we're calling for 5 degrees. We're right there. Second stage, not bad at all. 7 degrees superheat. We're calling for about 5 degrees. That's close enough. Subcooling about 22 degrees. We're on the tail end of being high. As far as our saturation temperatures, we're mixing some outside air, so I'm not too worried about that. That's our targets, basically. Our target's a little bit lower, but it's kind of getting where I have the probe is probably more on point for the bottom set of the evaporator. The top side kind of gets some of the outside air. So if I really wanted to get technical, I could go in there and close the outside air damper, but I don't think we need to. This thing's doing everything it could. Let's see. Temperature split's about 17 degrees. It's pretty good. And that's actually getting building air, not outside air. So remember, like I said, the top half of the evaporator is getting a little bit of outside air. So technically that number is going to be higher. But anyways, we're good. Airflow is decent. Delivered capacity, 60,000 BTUs. We're calling for 63. Oh, we're calling for 60, yeah. 63,000. So this thing, refrigeration-wise, is kicking butt. Don't see anything wrong with this guy. Compressors, I mean, everything's doing the best that it can. So next, let's start checking current on things to see if anything's overamping. Then we'll get the thermal imaging camera out and we'll look at the disconnect switch and see if that thing's overheating also. Looking at this guy, that you see, that big giant yellow thing, that is the circuit 1 fuse and lug is severely overheating. Look at that, whoa. And the other ones aren't doing it at all. It kind of looks a little discolored too. Let's see, insulated screwdriver, so be very cautious. Now it's making a connection. It's making connection, but it's got a bad connection in there because it is severely overheating using the thermal imaging camera. Bad. Look at that. Look at it. It's all the way up in the wire too. That's crazy. Let's check current on that. I'm curious what kind of current we're pulling on that right now. We've got somewhat low voltage here. There's no voltage drop across the disconnect switch. We've tested it. So 195, 1 to 2, 194, 2 to 3, 196, 1 to 3, 195 right in there. But that first leg is pulling 33 amps and it's like 90-degree wire, and then the other ones are like in the 70s. So it's got to be a bad connection right in here is what it's looking like to me. So we definitely need a new disconnect switch on this guy. we're gonna proceed to see if we can test to see if anything else is overamping. All right, we're gonna go through the line. Condenser fan motors are allowed to run 1.42. That's one of them. That's the other. So we're under current on both condenser fan motors. Compressors, let's start getting on those. 11.7, we're allowed to run 13.4. 11.7 for that one. Again, we're allowed to run 13.4. Indoor blower motor, 4.5, and we're allowed to run 7.5. So we're not overamping on the compressors or the indoor blower motor or the condenser fan motor. We just need to put a new disconnect switch on this guy. So we repaired some potential electrical issues. We eliminated all that nasty rat's nest of wire nuts and stuff on the line voltage coming in. This contactor was slightly burnt, but it wasn't horrible, but we were changing them, so I changed all three. That way we could terminate directly with the lugs. Yeah, that's it. So we changed the capacitors, both of them. One of them was testing bad, one of them was kind of low. So we changed them both, and we just need to get a new disconnect switch because that line 1 is just getting really hot and overamping basically. So this guy's running. We'll leave it like this for now. We'll come back and we'll change the disconnect because I don't have one today. So I went downstairs, we're cleaning up, and we have to see this unit turn back on because remember, compressor 1 and 2 were jumped together and I don't know why. So we don't know if there's something wrong with the thermostat because they had Y1 and Y2 jumped onto Y1. So because we corrected it, I went downstairs, that we're all done, and turned the thermostat on. There goes one compressor. We want to hear the second compressor turn on in a few minutes to indicate that the thermostat's working correctly. So it's very important. If you use jumpers, you need to make sure that the thermostat is working too, because it's very easy for you to jump it out up here and it works, but then it have a bad thermostat downstairs, okay? So typically, I always make sure the thermostat is typically working first and then run jumpers after that. We just didn't do it in this situation, so. All right, second stage turned on. We ended up pulling the panel off because we didn't hear it, but it turns out it did turn on. We just didn't hear it turn on. So both compressors are running independent of each other, so that's good. And we'll be back with the disconnect switch, and then we'll end up probably replacing that conduit down there and then clean it up a bit. All right, we are back today. We're gonna change out this disconnect switch. So I've got the main turned off, locked out, so that way nobody can turn it on. I know I don't show out lockout, tag out enough, but you know, it's just one of those things. I'm always in a rush to do it, and I don't always turn my camera on when I'm locking things out, you know. So anyways, we're good, we're locked out. We're gonna go up top and get this disconnect switch changed. We are redoing a few things because the LB, there was a bunch of wire nuts in there. You're not really supposed to have those in there, so we'll put a box. We do have to support it though because it's kind of moving. All right, we already got our conduit ready. Now I mounted the disconnect. This is not my favorite one, but you know, whatever. Mounted the disconnect. We got a chase nipple going through. We were able to get it tight enough that we could get the nylon bushing or plastic bushing on the other side. Just helps to protect the wires when you can. I did the same inside there. We're gonna come up with the conduit directly into here, up and over, and then out of here into the unit, you know, obviously all that. My electrical box in here, we've got plenty of length. I use Polaris splicing lugs, torqued them down. They're nice and good. I'm not gonna put them in the box yet because we still gotta mount like a piece of unistrut on the back of it. So I'm gonna have to drill through the back and I don't want wires in there. I'm gonna tape these up just to prevent, even though you don't really have to tape them, I'm still gonna tape the ends and then we'll get it hooked up there. I'm sure that there'll be some people telling me I do it wrong, and that's fine. I'm always looking to learn something new, but the way that I torque down lugs is to come in here with a regular screwdriver, tighten them down, run them. So you go tight, loose, tight, loose, tight, loose. You'll notice every time it'll go tighter. What I'm doing is I'm smashing the wire, but before I torque it, I'm gonna loosen it. Then we'll come in with the torque driver, set at 35 pounds. I can't do it with one hand, but you get the point, right? I got to get in there so I don't break the tip of the screwdriver. But that way I've torqued down the wire, I've smashed it down, and then now we're actually setting the torque of the screw. That's how I've always done it. Okie dokie. So we came into here because we already put the new contactors in yesterday, so the power came right into the top of the lugs the way that it was. We got it under here, secured, everything protected, grounded like it should be back in there. And then all in here looks pretty good. We still got to check phase rotation and then put some new fuses in there. And then we still got to mount that box to the unit. This guy takes 45 amp fuses, so I've got those in there. Power's still off. Normally, like I said the last time, I like to leave fuses in the disconnect, but this silly disconnect right now, I'm having a hard time getting disconnects. This silly one is so small that you can't fit extra fuses in it, so I just put them up in here. So we got 3 extra fuses there, and then we've got extra control voltage fuses right there that we always leave. Whenever we do work, we always try to leave extra for the next guy. You come up here and it's like, oh, it's just a control voltage. You've got one to change, and then you could diagnose where your problem is, whatever. Same thing with main fuses. Makes it a lot easier when you come out on a weekend to do a service call. At this point, it's time for us to go ahead and turn on main power. I got to unlock the breaker or the disconnect downstairs, and then we got to check phase rotation and make sure everything's rotating the right way. Now, on this unit, these are 3-phase scroll compressors. On a 3-phase system, if you interchange 2 of the lines, you can change the rotation. And the problem with the scroll compressor is that it cannot run backwards. Since we've done a bunch of electrical work and the wires aren't really marked, I don't know what's A, B, and C for the phase, so we got to check it to make sure it's wired correctly. Also, the indoor blower motor, we don't want that spinning backwards either, because that's also 3-phase. So we just got to check that, and then we'll go to the hardware store and get a piece of unistrut mounted to the side of the disconnect or the unit, and hopefully be done with this guy. All right, we have power turned back on, so let's go ahead and test right here. 200 volts there. Let's see, we're a little bit higher today. 199. 199. So we've got 3-phase coming into the unit. Should be 208 volts 3-phase, but it's a little low. Pretty typical. I'm gonna pull the control voltage wire so the unit doesn't start by itself. And we're gonna fire it up. Didn't blow up, that's a plus. That's a backwards compressor. I could tell just by the sound right away. So we're just gonna switch the phases real quick. We'll do it at the disconnect switch, it'll be easier. Right here. Switch the phase, we'll do 2 of them, and then it should be the right rotation. We'll check again. I actually just switched them right here, it was easy enough. Okay, so we should be able to turn it back on. Again, disconnect or control voltage is turned off. Let's do indoor blower motor is running in the right direction. So that's good. Let's test the compressors. Sounds good. Sounds good. We good to go. Turn it off. We're gonna put all the panels on, and then we'll fire this guy up and make sure it starts up. For those that are wondering, I use the HIC Micro M30. Now it's a bit overkill for everything I do. I bought it for my home project, but I did pick it up from TrueTechTools.com. If you go to TrueTechTools.com and use my offer code BIGPICTURE, you can get an 8% discount on most of the items on their website, and then I get a small commission. It's an affiliate code. So we've got this disconnect switch right here, and you can see that it's been running for a little bit. We have nice even heat. The lugs at the top don't look that bad. It looks nice and even, nothing abnormal. We can also, well, actually I already put the cover on right there, but I've got it jumped out. We can also go down here. I did put splicing lugs right here. We can give those a look. They look nice and even. Now you're seeing the roof too, because the roof's kind of hot. But everything looks nice and even, nothing too crazy. So yeah, we're looking good. So we're still gonna go get a piece of unistrut to mount the back of that box so that way it's supported. And then we'll put the disconnect cover on. But I think we're gonna be good, and I think we found the problem for the blown fuses. I just took a piece of unistrut, bent it, or cut it, bent it, put a little solder on it real quick just to hold it together. Scuffed it up with some Scotch-Brite, painted it black just to kind of keep corrosion down. And then we bolted it to the box through the back. I got strut little clamp things in there, and then just sealed up the 2 little holes down in the bottom from the silicone. Yeah, and that's good. This thing's done. It's about as good as it's gonna get. Seriously polishing a turd. But AC's cycling on and off, everything's good. We checked the pressures already, all is well, so we're gonna tell the customer to keep an eye on it.
You know, disconnects can be tricky because oftentimes we've had probably 4 or 5, maybe even 6 of them this summer, where you get a service call, you have blown fuses, and the first thing I do, check for direct shorts to ground, nothing, test everything, nothing. In this situation, this service call came in a really busy time, so we got over there, we didn't find any direct shorts, we changed the fuses, it started running, we told them we were super busy, we'll be back. Like, that's what happens when you get all these. And a little bit more detail to that is that majority of my customers don't do routine maintenance anymore. So it tends to be kind of Pandora's box, like this one, right? We're not in there on a regular basis monitoring, looking. It's like they are reactive now. So they call when it's broken, and it's like, oh, well, we have to go through, does it need to be cleaned? Does it need all this stuff? So when they don't do routine maintenance, it makes it a little bit more difficult when you get into a heat wave and all of a sudden you have 9 service calls, 10 service calls a day, and you're like, how do I, we're trying to send everybody to where we can get 1 to 2 of them done a day. We try not to rush everybody, but in certain times when we're super, super busy, we will tell the technicians like, hey, head out there, get it going. We'll come back to finish it up, and that was the situation here. We went out there, nothing jumped out in our face that was a problem, changed the fuses. The unit ran for a week or 2 after. And then once things kind of calmed down, this wasn't a high priority because it was still running. We came out when things were a little bit slower and went through it and found a bad disconnect switch. But they can be a little tricky because in this situation, it was only blowing the fuses when it was really, really hot. And since we were a week and a half, 2 weeks out of the heat wave, it still hadn't blown it again. So then that's when you really get in there and you start using your tools, use your senses, look around. Now, there was a couple little things that I found. I corrected them, right, to kind of eliminate those from our equation of potential problems. And then I think I found the real culprit, which was the disconnect switch. And clearly, we weren't seeing voltage drop. We weren't seeing severe discoloration. So it was the thermal imaging camera that helped me to really find that problem. I highly suggest looking into tools like that can, help you diagnose better, right? Thermal imaging cameras are great resources. Now, that HIC Micro M30, that is a bit overkill for what most technicians. That's a really expensive thermal camera. You don't got to go buy the most expensive one. I mean, if you have the means, certainly, go for it. But just a simple phone thermal imaging camera, inexpensive one, because really you're just looking for basic temperature differences, and even some of the more inexpensive ones could have very easily found this problem. Okay. So I highly suggest, tools. Tools are very important. I mentioned in the video that if you guys are interested in purchasing tools, go check out TrueTechTools.com. It's a great way to help support the channel by using my offer code BIGPICTURE, one word. Now, that doesn't work on every tool that they have because there's some things that they can't give discounts on because of manufacturer's rules. But for the majority of them, Big Picture, one word, will get you an 8% discount on most of the items on their website. And it'll definitely help you when you have tools, to be able to diagnose a little bit better. Okay. So I found that the disconnect switch was the problem. I went ahead and replaced that. And then I made a few upgrades, replaced the LB that they had wire nuts in and put a proper junction box in there. Supported the junction box because you got to think about the big picture here. If I didn't support that eventually, it probably would have broken, potentially caused some issues. So we supported it. Nothing too fancy. I just took a piece of unistrut, cut the ends, kind of mitered it, right? And then bent it and then soldered it with some, solder that can stick to the galvanized whatever, right? And then just, scuffed it up and painted it. Nothing too crazy. We weren't trying to like win a beauty contest or anything. It's functional, it works, and it supports the junction box, right? So always be cautious with that stuff. Always try to think big. I'm not perfect. I miss things. You guys see things that I missed in this video. You have other suggestions. Feel free to leave me a comment. I am not afraid of criticism because with criticism comes knowledge, right? If you have criticism where people are giving factual information or they're trying to give you tips and pointers, as long as I don't let my ego get in the way, I can learn from that. Now, you don't got to be a jerk when you criticize someone. You can give them, some honest feedback, right? And I'm always open to that. So if you guys have feedback in any of my videos, feel free to leave it in the comments. You can shoot me an email to hvacrvideos@gmail.com. I'm 100% okay with it, okay? I really do appreciate all the support and the comments that you guys leave. So I'm very curious in the comments. Let me know, would you have done this call differently? How would you have approached this? Would you have changed the disconnect switch, or do you think that's normal to see that temperature difference on one leg? Now, I will say that if I saw that temperature difference on 2 legs, it could be that there's some single phase components in that unit. The condenser fan motors are single phase. So it is natural that even though that's a 3-phase unit, that you are going to see different currents on 2 of the 3 legs. So when you are running that unit full bore, it's the middle of the summer, it's very common for two of the legs to have a higher current draw than one of the legs. So that doesn't necessarily mean that's a bad thing. And you will see a little bit of a temperature change, not much, but a little bit. This was extreme though. But I'm curious, what would you have done? Would you have done it differently? Do you think that, that disconnect was fine? Leave it down in the comments. Give me some feedback. Again, I'm always looking for feedback. I really appreciate you guys, as usual, making it to the end of the video. If you haven't already, please consider going to my website, hvacrvideos.com. We have merchandise available on there, hats, beanies, sweatshirts, all that good stuff. Great way to help support the channel. I already mentioned TrueTech Tools. Great way to help support the channel. TrueTechTools.com. Use my offer code BIGPICTURE at checkout. It'll give you an 8% discount on the majority of the items on their website, and I get a small commission from that because it's an affiliate commission. You can also support the channel via PayPal, Patreon, YouTube channel memberships. There's links in the show notes. Last but not least, the easiest way to support this channel, literally, is just watch the videos from beginning to end. That really is the easiest way. Just takes a little bit of your time, doesn't cost you a single thing. Thank you so very much. I really do appreciate you, and we will catch you on the next one.